Hi class, we are now going to be covering 3.5 and 3.6 together. We're going to be dealing with matter in physical and chemical changes and properties. So different kinds of matter have different properties. A physical property is one that a substance displays without changing its composition. A chemical property is one that a substance displays only through changing its composition. I'll give examples of these. A physical property would be tearing a piece of paper up. You can tear the piece of paper up into many little pieces, but it's still a piece of paper. It hasn't changed what it is. A chemical property is changing completely. I burned this piece of paper. I cannot put this piece of paper back now because it's gone to ash. That's the difference. I can tear this piece of paper up. I can tape it back together. It may not look exactly the way it did, but it's still a piece of paper. Once I burn this piece of paper, I can no longer go back and make it a piece of paper. That's the difference between a physical property and a chemical property of what happens to it. Differences in physical and chemical properties. So the characteristic odor of gasoline is a physical property. So the odor is deemed to go with gasoline. Gasoline does not change its composition when it exhibits this odor. It's a trait that goes with the gasoline. The flammability of gasoline is a chemical property. Gasoline does change its composition when it burns. So a chemical property is the fact that we know that gasoline is flammable. And if it catches fire, it will actually change into something else. It's no longer gasoline. Physical properties are characteristics observed or measured without changing the identity of the substance. So the substance does not change based on what we can determine or measure from it. So this includes shape, physical state, boiling and freezing points, density, and the color. Properties are characteristics used in identifying and describing. So a physical state, is it a gas, liquid, or solid? What color is it? Odor, luster, that's shine. Does it conduct electricity, density, solubility? So these are physical characteristics that you can look at and see. If you had a substance and you didn't know what it was, you would start looking at some of the stuff to determine what it is and then go on to the next step. So the physical properties do not change what the object is. Physical properties of copper, for instance, it's reddish orange, it's shiny, that's the luster. It's an excellent conductor of heat and electricity. It's a solid at 25 degrees Celsius, room temperature. It has a melting point of over 1,000 degrees and a boiling point of over 2,000 degrees. So this is an example of describing the properties of copper. Chemical properties. Chemical properties, this is a little harder to understand. Chemical properties are those that describe the ability of a substance. So this is, for instance, we know that gasoline is flammable. So it's the ability for it to be flammable. So you don't want to keep flame by it. Whereas, put flame by water, nothing. We're not worried about that. That doesn't have the same property as something that gasoline has. So this ability of a substance to change into a new substance can only be observed by changing the identity of the substance. So only when this chemical reaction is occurring and changes it into something else do you see what those properties are. So if something has the ability to burn, you're not going to see the new property unless it's been burned or going through burning. Ability to tarnish. Iron will tarnish. Silver will tarnish. Tarnish is that it's slowly corroding away. So silver, you don't want this black tarnish on it because what it's doing is it's interacting with the oxygen and it's just slowly decomposing. It's no longer silver. It's silver oxide. Ability to rust, same thing. Rusting will, if you have iron and it's now a rusty nail, eventually if that nail keeps combining with the oxygen, it will just disintegrate. It will no longer be iron, and it's iron oxide, and it will just rust away. Ability to decompose. Decomposing is a chemical reaction because you had a tomato and now the tomato is decomposed. You're not going to want to eat that tomato anymore because it's no longer really a tomato. It's being decomposed into something else. Ability to react with other chemicals, things that will interact with each other. Instability, a property of a compound or substance is that it might be very unstable, something explosive. Ability to do acid or base reactions, something that will, if it's an acid, it will react with the base. a physical change is a process that changes the physical properties of a substance without changing its chemical composition. So no reaction takes place. What you start with is what you end with. Unlike with chemical properties or chemical changes, what you start with is not what you end up with. So iron rusts in moist air. That's a chemical property. It describes which chemical changes will occur. We know that iron will rust in moist air. That's a property that goes with iron. However, a physical change, tearing a piece of paper up, no reaction takes place. It's still a piece of paper. So chemical changes is a process where one or more substances are converted into one or more new substances. This is where a chemical reaction occurs. If you start with something and you end with something else, a chemical reaction has occurred. Different elements or compounds are present at the end of a chemical change. So an example is pennies tarnishing, burning gasoline. You start with gasoline, but you don't end with gasoline. The reaction of hydrogen and oxygen to form water. You start with two elements that are gases, and now you have liquid water. Digesting food, the food is gone. It's no longer what it was. Chemical changes are the process by which substances actually change into new substances. So they describe, chemical properties describe what chemical changes will occur. So chemical changes, when a chemical change takes place, the original substance is turned into one or more new. So during a chemical change, a new substance is formed. So you have a new composition, new chemical properties, and new physical properties. This means that the atoms will change partners in a sense if they have combined from one compound. So think about H2O. If we can go through a chemical change of breaking down water, then water, the hydrogen atoms and oxygen atoms will separate, and they might join with another element. That's what it means. It's a new composition. An indication of a chemical change is a color change, odor change, heat, giving off heat during a reaction. That's where those heating pads come from. If you ever had those disposable ones where you break the pad, there's a chemical reaction taking place, and that chemical reaction taking place is giving off heat. Same as an ice pack. Production of cold, fizzing, foaming, bubbling. These are all indicators of chemical reactions. Not all 100%, but in most chemical reactions that you do, these are things that you look for. Sound produced, you can hear popping. Light given off, a precipitate, that's a fancy word for solid being formed. That's the word we use. And oxidation, which is rust or tarnishing. So kinds of chemical properties from chemical changes. A chemical property, the susceptibility of iron to rust. Iron has a chemical property that we know that if we leave it out into the environment enough, it will start rusting. It will interact with oxygen, and it will go from strictly iron atoms to now iron and oxygen atoms, and that is where the rusting takes place. It is no longer iron by itself. It is a new compound completely, and that's why it's rusted. Iron has a chemical property of rusting. That's where the iron 3 oxide comes from. It is no longer just an iron nail. How matter changes in chemical reactions. So matter undergoes a chemical change when it goes a chemical reaction. Excuse me. So if you start with something, that's the fancy word of starting materials. We call those reactants. And what we produce after a chemical change has occurred, we call products. So in a chemical reaction, the substances are present before the chemical change are reactants. So that's the starting material. So think of a cake. You have eggs, you have flour. If you're making it from scratch, you have eggs, you have flour, you have oil. You have all the starting materials. Those are reactants. Then you mix them in certain proportions and you stick them in an oven, and the heat causes a chemical change. Why is it a chemical change? Because you're not just eating eggs, you're not just eating oil or drinking oil, you're eating a cake. It is a new product made from starting materials. That is a chemical change. What you started with is not what you ended up with. And that's what this means. You have reactants, we have an arrow, this fancy arrow pointing towards products means that a chemical change occurred and new products were produced from starting materials. State changes. So transformations from one state of matter to another, such as solid or liquid to liquid, are always physical changes. So state changes, transformations from one state of matter to another, such as a solid to a liquid, are physical changes. That means water is a perfect example. Water can go from a steam to a liquid to a solid, and it's still water. That is a physical change. If you look at the breakdown of the composition, it is always H2O no matter what state it is in. That's a physical change. Ice melts, it looks different, but it's still H2O. Solid, ice, and liquid, still H2O. So melting is a physical change. In a chemical change, the matter does change. So the word chemical tends to tell you something. What you start with is not what you're ending up with. There is something going on there. Matter does change its composition. For example, copper turns green upon continued exposure to air because it's reacting with gases and air to form new compounds. They call that like a patina, I think it is. This is a chemical change. Same as iron rusting. It is going through a chemical change. It may be a very slow chemical change, but that iron is rusting away. Give it enough time, it's going to be gone completely. Titanic is disappearing. There will be a point where Titanic will no longer exist in the way that we know it because it will rust away completely. And the only things that will be left over are the parts of it that are not capable of rusting. Even James Cameron has said in the 20 years that he had went in difference, he can see the visual change of what's happened to Titanic. Physical change. The atomic or molecular composition of a substance does not change when the substance displays its physical properties. That's a fancy way of saying that a physical change, the compound or substance is still the same substance. It's not changing even if it looks different. The atoms are still there. H2O is water. No matter whether it's solid, liquid, or gas, it's still H2O. That's on the atomic or molecular level. That's what it means. The boiling of water is a physical property. The water will eventually evaporate away, and if you catch the steam, you can check it, it's still H2O. A physical property, the boiling of water. Boiling is a physical change. When water boils, it turns into a gas, but the water molecules are the same in both the liquid water and the gaseous steam. A physical change. So now we're going to look at different states of compounds and how they change. So a physical change occurs in a substance if there is a change in state. This is an example of melting, which goes from a solid to a liquid. A change in the physical shape means change in size. As an example, no change in the identity and composition of the substance. So physical change is a process that changes the physical properties of a substance without changing its chemical composition. Again, water is a perfect example. Change of state, water changes from a solid to a gas to a liquid, and there's fancy terms for that. That's what all of these mean. If you go from a solid straight to a gas and you bypass the liquid form, it's called sublimation. Something like that would be dry ice. Dry ice is solid CO2, but once it comes into contact in the air, you start seeing that fancy smoke that they use. That is going straight from a solid to a gas. And if you go from a gas to a solid, it's deposition, I think. I'm probably not saying that right. And then a gas to a liquid, condensation, and vaporization is liquid to a gas. That's evaporation pretty much. Solid to a liquid is melting, and liquid to solid is freezing. So dissolving sugar in water, that's a physical change, but sugar is still in the water. You can separate those out by evaporating the water. And breaking glass, still a physical change. The shape may have changed, but it's still glass. Ask yourself, is what you're starting with, do you still have it after the change? If you do, then it's a physical change. The difference between chemical and physical changes. The difference between chemical and physical changes is seen on the molecular and atomic level. The simplistic way to put this is that we're dealing with atoms, and these atoms are combined in certain ratios. And if it goes through a chemical change, those atoms switch partners. So think of dancing. They are switching partners and taking on new dancing partners, and when they do that, they create new compounds. Physical change, that doesn't happen. So in a physical change, the atoms that compose the matter do not change their fundamental associations. That means water is still H2O no matter what physical state it's in. In chemical changes, atoms do change their fundamental associations. That means different dancing partners. And when they change their dancing partners, they now are a new substance. A physical change results in a different form of the same substance. Water is still water. And a chemical change results in a completely new substance. Iron atoms now combined with oxygen, they are a partnership, and this is where rusting comes in. It's iron oxide. So vaporization, you push the button on a lighter without turning the flint. Liquid butane vaporizes to gaseous butane. The liquid butane and the gaseous butane are both composed of butane molecules. This is a physical change. It went from liquid to gas. It's still butane. So butane will change from a liquid to a gas the minute it hits the air. This is a physical change because it is still butane molecules. Burning, a chemical change. Push the button and turn the flint and it'll create a spark. And now you produce a flame from those butane molecules. The butane reacts with oxygen. The oxygen allows this to happen in the air, and it forms carbon dioxide and water. You may not always see the water because it could be a gas, but this is a chemical change. Why? Because ask yourself, is butane still there at the end? And the answer is no. You started out with butane and oxygen. You brought heat into it that produced a flame, and the new products, what was produced is carbon dioxide and water. Distillation. Distillation separates mixtures through physical changes. So remember when we were covering mixtures? Mixtures can be physically separated. They may not always be easy to be physically separated, like I showed you in that picture of that compound being poured and the solid staying in the top and the liquid going in the bottom. But you can do separations on some of these. They're just a little bit more complicated. The distillation is one of them. This is, in a sense, a purification method. This means that you start out with the compound and you are going to use its properties to separate them out. So you can have so it's a purifying. You separate them out, and maybe you want one of the compounds without the other compound, and now you can have it pure because based on the properties, you know how to separate these. So heat is used to mix on a mixture to boil off the more volatile, easily vaporized liquids. So what this means is that you have a solution and you put it on top of a flame. In this, you have two different compounds, let's say. One of them will hit a certain temperature, and when it hits that certain temperature, it's going to evaporate away. And while the other one will still stay in solution form. So the one that's easily vaporized, that means volatile, will be forced to go into this tube, and it will go down here. Now what you don't see here is that there's cold water. There's two different layers in here. There's one tube that forces the molecules from this, and they're in a gas. It forces them to go this way, and then it forces them to go in here. What happens is that once there's another little tunnel here, and cold water goes in this way and shoots out that way. When this gas comes into contact here in the condenser, just exactly what it means, it condenses back into a liquid form, and it's now being collected here in the receiving flask. So this is how they purify. So when you hear of distilleries during like alcohol, stuff like that, you'll hear commercials. This is distillation. This is how they purify. Filtration, this is a picture I had shown you, not this picture, but exactly of this. In lab, you'll do things like this. You can have, for example, a sample of water and sand. If you pour that into this funnel, and you have a paper funnel here to block it, the sand will stay in the filter, and the water will go into the bottom. So this is an easy filtration process to separate these two compounds. All right, so let's take a look at some examples. Classify each of the following as a change of state or a change of shape. I believe I have all the answers, so let's just break them down. I do. Okay, so chopping a log into kindling wood. Ask yourself, is it what you started with? Is it the same after whatever took place? And in this case, yes, it's a log, so it's just a change of shape. Water boiling in a pot. Is the water still there even after it's boiled away? And the answer is yes, it's steam. Can't always see it, but it's steam. Ice cream melting. That is, sadly, if it's melted and you don't get to eat it, it's still ice cream. It's just really runny. So it's a change of state. Ice forming as a freezer is a change of state because if it's water, then liquid water, and it freezes, it's now a solid. That's a change of state. Or excuse me, that should be a change. Change of state. And cutting dough into strips. That is a change of shape. We're changing the shape of what it is. Here are some charts again from another chemistry book. I like these better because they give examples of both that are pretty good to understand. And then also the definitions for everything that I just covered. Classify each of the following properties as physical or chemical. Ice melts in the sun. So if ice is melting, but if it's still water, that would be a physical change. Paper burning. Do you have paper once this change has been completed? And the answer is no, you do not. So you have a chemical change. A silver knife can tarnish. Can you, once the tarnishing has started, can you get back that silver? No, you cannot. It's a chemical change. A magnet removes iron particles from a mixture. That would be a physical change because that's just a separation. You're separating two compounds out.